Okay, this is revision session 2 for assessment window 2, paper 2, higher. So I'm going to start with the blue topics, and then I'll go on to the green, and then I'll go on to the orange at the end. Please feel free to stop, pause it, have a go at the questions before I go through them, and hopefully you'll find this helpful. So question number 1 is to complete a cubic from a table of values. So first we're going to complete the table of values. Now, to do this, it is a calculator paper, and I actually really like to use my calculator for this question. So in my calculator, I would type for this cubic, bracket, cubed, minus 2 lots of bracket, add 3. So essentially we're saying this is going to be what we type in our calculator, and then the x value is just going to change for each of these. So I would then put minus 2 in both of the places when trying to work out this one. And if you do that, your calculator is going to work it out for you. Now, putting those brackets in means that it's actually not so bad with a cubic, but when we square negative numbers, we know that if we type minus 2 squared in our calculator, it's just going to say minus 4. It doesn't understand that you're doing minus 2 all squared rather than minus 2 squared. So your calculator will get that wrong. So the brackets help to stop that happening. So we've got brackets here, because those are the 2 places where we have an input. So I've put minus 2 cubed, minus 2 lots of minus 2, add 3. Now we could work that out without a calculator, but we know it's going to be a calculator paper, so feel free just to type that in your calculator. Minus 2 cubed is minus 8. Minus 2 lots of minus 2 is add 4, and then we're adding 3. So we're going to end up with minus 1 there. Okay, and then the same for minus 1. Using my calculator, all I'm going to do is I'm going to go back, use the left arrow on your calculator, left, go back and change each of these minus 2s to be minus 1s. So actually, I should have just done it that way. So, sorry, that was minus 1. So now we're using the input minus 1. So minus 1 cubed minus 2 lots of minus 1. I've probably done my calculator to show you actually. Bracket, cubed minus 2 lots of bracket, add 3. So I don't know if you can see that, probably not. So I've just typed it in like that, and then I'm just going to keep changing the number in that bracket to whatever the input needs to be. So minus 1 and minus 1 for the next one. And that gives me 4. Ooh. And then I'm going to go back, left arrow, and change both of those to be 0. And that gives me 3. And then I'm going to left arrow, go back and change it to a 1. So we're doing 1 cubed minus 2 lots of 1, add 3, which is 2. And then I'm going to go back and change it to a 2. And that is 7. So now that we've got those values, each of these is a coordinate. So minus 2, minus 1 is here. Remember, going along the corridor upstairs. Minus 1, 4 is here. 0, 3 is here. 1, 2 is here. And 2, 7 is here. Now remember that because it's a cubic, x cubed, we're expecting to see this wiggle shape. Okay, it might just be kind of more like this. Or it might be really exaggerated like that. But a cubic, we would expect 2 turning points, or maybe both of them to be at the same place. If it was a quadratic, if it was just x squared, then we know that that would either be a positive parabola or a negative parabola. But we've got a cubic, so it's going to wiggle. So this shape actually looks okay. Now, here's the challenge, and I would suggest you use a pencil. I'm going to struggle on the screen, I think. So we want to go up. Oh, I turned it into a rubber, didn't mean to. There we go. That's going to be much easier on paper. Something like that. So we're just joining it up with a nice smooth line, and that would be our cubic. I've just put another example down here at the bottom. So if I was doing this one, again, I'm going to type it in my calculator, bracket cubed, add 2 lots of bracket squared, minus 1. So all we are doing is putting brackets instead of an x, and then that tells you where to put each of these numbers. So we can change both of them to be minus 3, or both of them to be minus 2, or both of them to be minus 1, and so on, and fill out the table and then plot it. That's just another example down there. I'm not going to do it. Hopefully that makes sense. Cool. Next topic, Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get at the end of 4 years. So compound interest is interest that you get on top of your money that gets added on at the end of the year. You're then going to get your new interest calculated on that total amount. So we're doing interest on the interest on the interest. So you could do £200,000 times, now I'm going to times by 1.015, and that's because I want 101.5%. I want the original 100% of my money, and I want an extra 1.5%. So I want 101.5%. So you could times by that, and that would tell you how much money you would have after 1 year. So let's do that and see what it is. 200,000 times by 1.015 is 203,000. What we then have to do is say, right, at the start of the second year, I've got 203,000 and I'm going to need to times that by 1.015 and see what I get, and do it again for the third year and do it again for the fourth year. But what we're essentially doing is 200,000 times by 1.015 times by another 1.015 for the next year, times by another 1.015 for the third year, and times by another 1.015 for the fourth year. So it just makes sense that instead of doing that 4 times, we're just going to say that this needs to be to the power of 4, because we want to know what the amount will be after the fourth year, after we've done it 4 times. So that would be my sum. Now, they've been a bit tricky here, and there's a real scope to lose a mark here. Hang on, let me work that out. 200,000 times 1.015 to the power of 4 is 2122272.71. It does then go 0.1, but I'm going to round it to 2 decimal places. Even though it hasn't said what to round it to, we're going to go 2 decimal places because it's money, so that makes sense. Now, that would lose me a mark. And the reason that would lose me a mark is because I've not read the question. It says, calculate the total amount of interest Katie will get at the end of 4 years. So we're not interested in how much money is in her bank. We want to know how much of that is interest. So my answer, I need to take away the £200,000 that I originally put in or Katie originally put in the bank. So my final answer will be £12,272.71. That is how much she's got in interest in those 4 years, and that's what they asked us. So just go back, double check that you've read the question and you know what it's asking you and you've answered it sufficiently. So the amount of money times by the interest rate, 1 point whatever it is added on to the power of the number of years, however many years you're going to do it for. Okay, Adam buys a computer. 20% VAT is added to the price of computer, and he has to pay a total of £900. Now, what's really important with percentages is we have to work out, has someone already done the change, or are we doing the change? Now, in this example, it says 20% VAT has been added, and then it's £900. So someone has already added that 20% on, which means that the number that we've got is not 100%, it's 120%. So a couple of ways to do this. Now, if I didn't have a calculator, or I mean, even if you did, you might want to write 120% is £900. That's going to get you a mark, just for recognizing that you understand that £900 is not 100%, it's had 20% added on. So 120% is £900. Now, from there, you might decide, well, the easiest way to do this would be to divide by 12. Oh, divide by 12. So 10% is 75. Sorry, 10% is 75. And so 100% is 750. And that makes sense, because if we then did 20% of 750, it would be 150, add it on, we get 900. So we're happy that that works. So that's one way of doing it. The other way of doing it is to say, well, I obviously had a number and I times it by 1.2 and I got 900. So I had a number, I increased it by 20%, times it by 1.2, and I got 900. So I could just do 900 divided by 1.2, and that would get me back to the original number. So 900 divided by 1.2 is 750. So 2 completely different ways of doing it. You've got a calculator, so either method is absolutely fine. It's likely that one of them makes more sense to you, and just go with whatever makes more sense to you. There's no right or wrong with that one. Okay, question, whatever we're on, I don't know. Question 4, I don't know. We've got a vector here, 1, 4. Now remember, this is a vector, not a fraction. I don't want to see any lines in vectors. Vector has a top number and a bottom number, but it's very much not a fraction, it's an instruction. So vector A is telling us to go 1 to the right. Remember, a vector, top number is left and right, bottom number is up or down. And if it's positive, we're going right, negative, we're going left, positive, we're going up, negative, we're going down. This vector, 1, 4, tells me I'm going 1 to the right and 4 up. It's an instruction. It's not a coordinate. It's a direction. We are going 1 right and 4 up. For vector B, we're going 3 right and 2 up. It then says, write down as a column vector, A add B. So what if we do the vector A, we go 1 right and 4 up, and then we do the vector B, we go 3 right and 2 up. Overall, what is going to be the resultant? What's going to be the vector that we move overall? So I can show my work in here and do 1, 4, add 3, 2. Now, unlike fractions, we can just add these, even if the top number, bottom numbers, whatever's different, we can just add these. So we know that in total, how much would we have gone across? Well, we've gone 4 across in total. And we've also gone 4 up on vector A, and we've gone 2 up on vector B. So overall, we've gone 6 up. So my answer for A add B, the resultant, the vector that we would go if we were doing both of them, is 4 across and 6 up. Now, what if we were to do 2 lots of A? So what if we were to do 2 of, oh, excuse me, sorry. What if we were to do 2 of these and 3 of these? So that would be 2 across and 8 up, and then it would be 9 across and 6 up. It's really quite a nice question, this one, because we've not had to deal with any negatives, but you might get negatives. It still doesn't change anything. So overall, we've gone 11 to the right, and we've gone 14 up. Done. Wonderful. Okay, so negatives just mean to the left. So if you went 5 to the right and 4 to the left, you'd end up going 1 to the right overall. Wouldn't really change the method there, but bear in mind that that might happen. Okay, the vector C is drawn on a grid. So C, actually we could label this, couldn't we? C is the vector 3, 2. It's gone 3 to the right and 2 up. From the point P, draw the vector 2C. Well, 2C just means doing C twice. So we would need to go 3 across and 2 up, which would take us to there, and 3 across and 2 up, which would take us to there. And use a straight line because I can. There we go. And that's it. And we want to show the direction because we don't want anyone to be confused on which way we're going. Has to go in that direction. You should be able to tell that those lines are parallel. So we can see that C and 2C are parallel. They're going in exactly the same direction. Yeah, that's it. Okay, Venn diagram. So we've got this lovely squiggly E up here. Now, this denotes the universal set. So I like to think of that as my universe. That is everything you know about in the whole universe right now. Everything you know about in the whole universe is in that set. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is your universe. If I start asking you about the number 10, sorry, I don't know a number 10. That's not in my universe right now. So that is everything you know about in the world right now is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then set A is 1, 5, 6, 8, 9, and set B is 2, 6, 9. So we now need to fill out the Venn diagram to represent this information. Now, this bit in the middle is called the intersect. So if it's in A and B, we can put it in the middle there. So I can put 6 in the middle because that's in both A and B. And I can put 9 in the middle because that's in both A and B. And they've got nothing else in common. So I'm going to put the 1, the 5, and the 8 in A, and I'm going to put the 2 in B. There we go. Now I'm not done because my universe is not complete yet. At the minute, I've got 1, 2, I need to put 3 out here, and 4 out here, 5, 6, and 7 out here, 8, 9. And just double check your universe, 1, 2, 3, 4, 5, 6, 7, 8, 9, has 9 numbers in it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got no duplicates. I've not missed any out, so I'm not going to lose any marks for that. And I've made sure they've already done it for us, but just double check that A and B are labelled and double check that you've got the universal set up there in the top left corner. Perfect. A number is chosen at random from the universal set. Find the probability that the number is in the set A intersect B. So we've got two possible, well, the two big ones are this or this. Now, I like to think of this one as and this one as or, so like fish and chips. The other stupid thing I do to remember it, this one is called the intersect, and this one is called the union. Now, if you think about the intersect, it's where two things cross. So the intersect is this bit here. It's where A and B intersect. It's where they cross. Union, think about the United Kingdom. It's a union of countries. So we could be in Scotland or Wales or England, or it's a union. It's all the things coming together. So A union B is anything from A or B. So it's the union of them together. So the other way I used to remember it, which is slightly sillier, is that I think this one looks like a little grabby machine, like those ones at the arcades that you get. So it only picks up, it's only picky, it only picks what's in the middle. And this one looks like a bucket. And so anything can go in the bucket. That's my slightly more stupid way of remembering it, but it works for me. So we've been asked the probability that the number is in the universal set, and we're picking from the whole universe. So we know that this is out of 9 because we know that the universal set has 9 items in it. Find the probability that the number is in the set A intersect B. Well, there's only 2 numbers in the intersection, so my probability is 2 out of 9. Oh. Okay, on to indices. Write 3 to the power of 5 times 3 to the power of 4 divided by 3 to the power of 2 as a power of 3. Now we know that when we multiply, we add the powers, and when we divide, we take the powers away. So this would be 3 to the power of 9 over 3 squared. And we're going to take that away because we're dividing. So my final answer would be 3 to the power of 7. Anything to the power of 0 is 1. So that one's nice and easy. A negative indice, so this is asking you to do 3 to the power of minus 2. A negative indice makes the base number its reciprocal. So to use up that minus power, we're going to take the 3 and turn it into its reciprocal, which is going to be a third. So this is the same as saying a third squared. So to use up that negative power, we've made 3 turn into 1 over 3. And then we would actually square it, which means doing the top number squared and the bottom number squared. So 1 over 9. Whoa. Okay, we'll leave that one. Okay, simplify p squared to the power of 5. A power of a power, we times the powers together. The other way to think about this is, let's write it out. P squared times p squared times p squared times p squared times p squared, because it's to the power of 5. So we're timesing it by itself 5 times. So that would give us p to the power of 10 as our final answer for that one. And for this one, we're just going to look at each part in turn. Now, I find it a little bit easier to write these as fractions, personally. Might help you to visualize it. And then we're just going to look at each part in turn. So 12 divided by 6 is 2. X to the power of 7 divided by x cubed is x to the power of 4. And y cubed divided by y, well, you could put a little 1 here if you wanted, and that would be y squared. And that's my answer. A few more of those I think I've done. Okay, everything in this bracket needs to be cubed. So again, you could write out 5np cubed times 5np cubed times 5np cubed. And then we can do that. You might find that a little bit easier. Or you can say the 5 needs to be cubed, the n needs to be cubed, and the p cubed needs to be cubed. So we're going to end up with 125 n cubed p to the power of 9. Now, really common mistakes I would see with that is people would just do 5np to the 9. So everything in that bracket needs to be cubed. So there are 3 terms to worry about, and hence our final answer is But this one's similar to the one that we did on the previous screen. 32 divided by 4 is 8. Q to the power of 9 divided by q to the power of 3 is q to the power of 6, because we're taking away. And r to the power of 4 divided by r is r cubed, because again, we could put that little 1 there if we wanted. Anything to the power of a half, we square root it. So this is essentially saying the square root of 100, which is 10. And for part B, we've got 2/3. Now, the reason we square rooted here is because we root by the bottom number and do the power of the top number. So with this one, I'm going to do the cube root. And then the power is 2, so we're going to square it after. So the cube root of 125 is 5. And then we need to square it. So my final answer for that one is 25. Okay. Now, I do this method different to Mr. Hegarty. So I'm going to do it my way, but if you do it a different way, if you do it the way that Mr. Hegarty does on the video, then that's not wrong either. It's just different. So I'm going to do it the way I do it. Please ignore me if you don't do it this way, but we'll see. So let me write out the sequence. 3, 6, 11, 18, 27, 38, and 51. It's quite a lot of terms. We probably don't need to do that many. With a nth term, if we're going up by the same amount every time, then it will be a linear nth term. So like 3n add 5 or 5n minus 1. If it's not going up by the same amount every time, so for example, this has gone up by 3, this one's gone up by 5, this one's gone up by 7, this one's gone up by 9, and you kind of see what I mean now. We don't need to keep doing this to know what's going to happen. But there we go. We need to do the next difference. So if the first difference is not the same, if it's not constant, then we're going to need to go to a second difference. So this has a difference of 2, this has a difference of 2, this has a difference of 2, and this, and this. Now, whatever that second difference number is, you half it. Whatever that number is, so if it's 2, we half it, it's going to be 1. If that second difference was 4, we half it, that would be 2. That gives you the coefficient, the number in front of n squared. So in this case, it's going to be 1n squared. And you don't have to write that 1. I like to do it just so that it's there and I make sure that I've done it. So what is the sequence 1n squared? Because we know that at the minute, 1n squared is going to be helpful to forming our sequence. So what is the sequence 1n squared? Well, the first number in 1n squared is 1 squared, which is 1. And then we need to do 1 lot of 2 squared, which is 4. 1 lot of 3 squared, which is 9. 1 lot of 4 squared, which is 16. And 1 lot of 5 squared, which is 25, and so on. And we can do 1 lot of 6 squared and 1 lot of 7 squared, 49. And then we need to look at that and look at the sequence we're trying to get and say, right, how much more do we need? Well, we need another 2, and we need another 2 from 4 to 6, and we need another 2, and we need another 2. So actually, this is just n squared add an extra 2. And that's probably why it's only 2 marks. So my answer here is n squared add 2. It's quite a nice, easy one because it was just the square numbers, but 2 bigger. Then it says find the 50th term of this sequence. So to find the 50th term, we make n 50. So we're going to do 50 squared, which would be 2,500. Add 2. So 2,502 would be our answer to the 50th term of the sequence. We would just make n whatever position number that we wanted. I think I looked at that and thought that's quite an easy one. So I've done a slightly harder version. So we're going to do the same thing again. Let me write out the sequence just a little bit bigger for you so you can see it. So this is 6 bigger, 10 bigger, 14 bigger, 18 bigger, and 22 bigger. And that has a difference of 4, 4, 4, and 4. If your second difference is not the same, you've done something wrong. Go back and check your maths because that number will always be the same. So we're going to half that number. And that tells me it's 2n squared this time, okay? Now, if I did 2n squared, it would be the square numbers doubled. That would be the sequence. So 1 squared is 1, doubled is 2. 2 squared is 4, doubled is 8. 3 squared is 9, doubled is 18. 4 squared is 16, doubled is 32. 5 squared is 25, doubled is 50. And 6 squared is 36, doubled is 72. Now let's see how much more we need. So to get from 2 to -1, I need -3. Oh, they're all -3. This is boring. It's another boring one. It's not hard enough. Okay, so that would be the sequence 2n squared minus 3. Now, what I was trying to get one that did is if, and it isn't in this one, but if this bit made a sequence, let's say, for example, that I needed 5 more, and then I needed 8 more, and then I needed 11 more, and then I needed 14 more, and so on. If these numbers were different, we'd need to do the nth term of this. And in that case, it would be 3n add 2. And then my answer would be 2n squared add 3n add 2. But annoyingly, it was another nice one where it was like that. If you only feel that you can get to this stage, that's absolutely fine, because that's going to get you a mark. So do the second difference, half that number, and say, right, well, that's 2n squared, and put that on the answer line and just be like, yeah, that'll be a mark, and I'm happy with that. Okay. Do your best. Okay. Phone calls cost y pounds for x minutes. So y, obviously we know y is this axis and x is this axis. Give an interpretation of the intercept of the graph on the y-axis. So this is the cost of my phone call. This is the number of minutes that I'm on the phone. So what is the interpretation of this? What does that mean? What does it mean if at 0 minutes we've got 0.5? Well, it means that before we've even made the call, as we're connecting the call, we've not been on the phone for any minutes, but to connect that call, it's going to charge us 50p. So the call charge starts at 50p, or we could call that, yeah, it's 50p to start the call, or it's 50p to connect the call. So we're not starting at 0, we're starting at 50p. And the life of me, I cannot remember the word. But yeah, we're starting at 50p, and then every time we go across. What's an interpretation of the gradient? Well, we haven't been asked to work out the gradient, but let's just do it anyway. To work out the gradient of a graph, we need to make a triangle and do rise divided by run. And you can make the triangle as big as you want. I'm going to go to, let's go, oh, well, let's just go to here, because that's quite a nice coordinate. Let's just make a triangle all the way down to that initial place. Why not? Why not? And then we'll do the rise divided by the run. So rise, how much has it gone up? Well, it's gone up by 7.5, because I started at half there, didn't I? So it's gone up by 7.5, and it's gone across in that time by 5. So rise divided by run is your gradient. How much has it gone up divided by how much it's gone across? So if we did 7.5 divided by 5, which I should definitely know in my head, is 1.5. So the gradient is 1.5. They've not asked me for it, but it's good to know how to work it out. So give an interpretation of the gradient. Well, what does that mean? It means that the definition of gradient is for every one across, it's how much it goes up or down. So in this case, for every minute you are on the phone, it's going to cost you an extra £1.50. Every minute you're on the phone, it's going to cost you an extra £1.50. That would be the interpretation of the gradient, what it actually means. Okay, a rectangular field, let's draw it. I love a drawing. A rectangular field is 15 meters long. That's a square. Try again. A rectangular field is 15 meters longer than it is wide. The area is 800. Work out the length of the field, give your answer to one decimal place. Okay, so we don't know how wide it is, but we know that the length is 15 longer. So I'm going to say that the width is x, and I'm going to say that the length is x add 15. And we're being told that the area is 800. Now, whenever in maths they tell you the answer, it's best to make an equation on how you would get to that answer and then solve it. So how would we get the area of the field? We would do base times height. So we would do x times x add 15. Now, I wouldn't write that like this. That's very confusing. The best way to write that multiplication is to use brackets. So we're saying that x times x add 15 needs to equal 800. We're saying base times height is 800. That needs to make sense. And then we can work out what x is. So this would be x squared add 15x equals 800. And here we have a quadratic. Now, a quadratic can only be solved if it equals 0. So I'm going to take 800 away from both sides. I'm really not being very consistent with the colour I'm using here. I hope you're all keeping up with me. X squared add 15x minus 800 equals 0. Now I can try and factorise that, but I have to be honest, my multiplication of 800 is not great. And to be honest, they said give your answer to one decimal place. So I don't think it's going to be a whole number integer solution anyway. So I'm going to use the quadratic formula. So remember that the quadratic formula is minus b plus minus square root b squared minus 4ac all over 2a, where a is the coefficient of x squared. So in this case, that's 1. B is the coefficient of x, so in that case, that's 15. And c is your constant term. So I'm going to type in my calculator, minus 15 plus or minus the square root of 15 squared minus 4 times 1 times minus 800 all over 2a, which is 2 times 1. Now, you can't put a plus minus in your calculator. So the first time we do it, we're going to put the plus. And the second time we do it, we're going to put the minus. And that should give us the two different solutions, because we know that quadratics can often, don't always, but have two solutions. Times minus 800 over 2 times 1. Okay, so that has given me 21.76 as my first solution. Let's do a few decimal places. And then obviously if I go back and change it to a minus, we get minus 36.76. Now, in the context of this question, a negative number actually doesn't make any sense, because we know it's a physical length, it's a field, so it's not going to take a negative length. So we can go ahead and disregard that option. Don't always assume that the minus one will be the one you don't need. Just, you know, do both and then disregard it. So 21.7617 is the answer that I've got. Now that is the width, isn't it? That's this one. And it wants it to one decimal place. So that's fine, 21.8. But they want the length, so we know that that's 15 bigger. So let's add 15 to that. 21.8 add 15 is 36.8. There we go. So 36.8. And we could just check if I times those together. Obviously, I've rounded it, so it's going to be slightly out, but that gives me 802.24. So we know that it makes sense. If we hadn't have rounded it, it would have been absolutely perfect in 800. So there we go. So we formed an equation. And the way to form an equation is to say, right, what do I know? How would I normally do that? Base times height, and then make an equation, just letting x be whatever you don't know. Here is a circle, centre O, and the tangent to the circle at the point 4,3 on the circle. Yes, find an equation of the tangent at the point P. So we would like the equation of this line. We want the equation of the tangent. Now, the equation of a circle is always x squared add y squared equals the radius squared when it's centered at the origin. And you will only ever come across examples where it's centered at the origin at GCSE. If you do maths at A level, you'll see examples where the circle is shifted around the Cartesian plane, but you're not going to see that at GCSE. So at GCSE, it'll always be x squared add y squared is the radius squared. And hopefully you can see that the radius, because we're cutting the y-axis at 5, and the centre is at the origin, and -5 and 5 and -5, the radius is 5. The equation of a circle is x squared add y squared is the radius squared. So we can see that it's x squared add y squared is 5 squared, so 25. So we know that the equation of this circle is x squared add y squared is 25 because the radius is 5. So that would be the equation of our circle. I don't think we need that, but it's good to know as well. Right, how am I going to get the equation of this line? Well, we've got a point that lies on the line, and we know that the equation of a line is y equals mx plus c. We've been given this point, So we need the gradient of this line. Now, the only way to get the gradient of that line is either to have 2 points that lie on it or 2 points that lie on a line perpendicular to it. So I know that the radius meets that tangent at a right angle. So I know that this makes 90 degrees. So if I can get the gradient of this line, then I can get the gradient of this line because they're perpendicular to each other. So one will be the reciprocal, the negative reciprocal of the other. So the gradient of the radius going to that point is rise over run. And we can see that the rise is 3 and the run is 4 because we're going along the corridor up the stairs. So it's gone up by 3 and across by 4. So 3 and 4. So 3 over 4 is the gradient. So if this line has a gradient of 3/4, then this line, the tangent, has a gradient of minus 4 over 3. So y equals minus 4 over 3x add c. And we need that y-intercept. We need to know if I carried on that tangent, where would it cross the y-axis? And we can see it somewhere up there. Now, to get that, we're going to use this coordinate. This coordinate lies on the tangent, so it can help us out. It's got an x-coordinate of 4 and a y-coordinate of 3. So I'm going to substitute those points into this equation because we know that if a point lies on the line, it will make the equation work. So 3 equals minus 4 over 3 times by 4 add c. And that is 3 equals minus 16 over 3 add c. And all I'm going to do is add 16 over 3 to 3 to get my answer. 3 add 16 over 3, which is 25 over 3. So c is 25 over 3. So the equation of the line is y equals minus 4 over 3x add 25 over 3. That would be the equation of my line. There is another way of doing it, and that's to use the formula y minus y1 equals m brackets x minus x1. I'm not sure which way your teachers taught it to you. So that's one way. The other way is to use this formula. We know that the gradient is minus 4 over 3, and then the x1 and the y1 are those points, that point that we had. So y minus 3 equals minus 4 over 3, x minus 4. And then we can just times both sides by 3 to get rid of this and expand it out. So 3y minus 9 equals minus 4x, add 16, and that becomes 3y, let's add the 9, so 3y add 4x equals 25. So you could do it like that, and to be honest, that's exactly the same as, that's the same as this. It's just in a rearranged format. So it's completely up to you. It doesn't really matter how you leave it. It hasn't told us what format to leave it in. So as long as it's the equation of a line, that's absolutely fine. If one of those methods makes more sense than the other, just do whatever makes more sense to you. And ignore me for the most part. Right, question number 9. I don't know if it's 9 or not. A cone has base of radius 2. The perpendicular height of the cone is 5. Calculate the surface area. Now, I've put the formula up here because if you were asked this, you would be given it. So the curved surface area of a cone is pi r L, where r is the radius and L is the slanted height. The slanted height. So this would be L. So actually, we don't have L on our diagram. So in order to get L, we need to do Pythagoras, because we know that the radius goes here and 5 goes straight up. So we've got a right angled triangle where L is the hypotenuse. So I'm going to do 5 squared, add 2 squared, and then square root my answer. And that is a square root of 29. To be honest, I'm just going to leave it as root 29 for now. Because I could write it as a decimal, but then I'm going to have to round it. So I'm just going to leave it as root 29, leave it in third form for now. Calculate the surface area of the cone. So the surface area of the whole cone is going to be the curved bit, and it's going to be the base underneath. So we also have pi r squared for the area of the circle itself. So we've got pi times the radius times L for the curved bit. Oh, curved is the same as circle. I was going to put C for curved bit. Let's just put CU, and let's put CI. So the curved bit is pi times 2 times root 29, and the circle is pi times the radius squared. Doing both of those things, the curved bit is 33.83598839, and pi times 4, pi times 2 squared, is 12.56637, blah, blah, blah. Cool. And we want to add those two answers together. And that gives me 46.4023. And it would say what to round it to in the exam, but I'm going to go 46.4 because that looks about right to me. Cool. So that's it. You might just be asked for the curved bit, but just pay attention to the question as to whether they want the curved surface area or the total surface area. Okay. Okay, there are some red counters and some white counters in a bag. At the start, 7 of the counters are red and the rest are white. Alfie takes at random a counter from the bag. He does not put the counter back in the bag. He then takes at random another counter from the bag. The probability that the first counter Alfie takes is white and the second counter Alfie takes is red is 21/80. Work out the number of white counters in the bag at the start. So I, again, like to draw this out. I'm going to draw a tree diagram with what can happen. And I'm going to put the outcomes on the end. So I know that it can be red or white, red or white, red or white. Outcomes always go on the end, probabilities go on the branches. So we know that the probability he takes a white and then a red is 21/80. So I know that this one here is 21/80. I know that this times this, 21/80. And we know that 7 of the counters are red and the rest are white. So we don't know how many counters are in the bag. So 7 of them are red. And we don't know what it's out of. I know that X of them are white. And again, I don't know what it's out of. But if I'm saying that X of them are white and 7 of them are red, then it's out of X add 7. So I've got 7 out of X add 7 and X out of X add 7. Now, when he's taking one out of the bag, he's not putting it back in. So to take another red would be 6 over X add 6 because we've taken one out. There's one less in the bag. Now, the probability of white would be X still because we've not taken a white out on the first pick. And that would still be out of X add 6. Because we are one less overall, but we've still got X whites because we've taken a red on that first pick. Going down at the bottom, I've got X over X add 7, but if I take another white out, it would be X minus 1 over X add 6. And if I took a red out, well, there would still be 7 over X add 6. So together, you can see that those branches still add to make X add 6 over X add 6, still add to make 1. Now, this is the one we're interested in. We're interested in this multiplied by this, giving me this. And I can set up an equation. X over X add 7 times 7 over X add 6 equals 21/80. And when we multiply fractions, we just do the top times the top and the bottom times the bottom. So 7x over X add 7, X add 6 equals 21/80. And I'm just going to multiply this up. So 80 lots of 7x equals 21 lots of X add 7, X add 6. Now, how can I make that a little bit easier? Well, I can divide by 7. That will make my life a little bit easier. So I'm left with 80x equals 3 lots of x squared add 13x add 42. So I need a bit more room really, don't I? Make room by getting rid of that. $80x equals 3x squared, add 39x, add 126. 14, yeah. And then take 80x away from both sides. So 39 minus 80 gets us down to minus 41. So 0 equals 3x squared minus 41x, add 126. I was really hoping that would divide by 3, but I don't think it does. So I'm just going to use the quadratic formula here. So minus b plus or minus the square root of minus b squared, b squared minus 4 times a times c all over 2a. So typing that in my calculator, let's see what we get. 41 plus square root of 41 squared minus 4 times a times c all over 2a. Good. So the positive solution gives me 9. And let's just check what the negative solution is using the minus instead of using the plus. Always good just to check. 4.6 recurring. Now, can we have 4.6 recurring counters? No, we can't. So we'll disregard that one and we'll take our solution to be 9, which means that x is 9. So we've got 7 red counters and 9 white counters, which would give us the answer that we need. Perfect. I think that's it. It's frozen, but I think that's it. I'm pretty sure I've done everything on the list. Use the Heggsy numbers if you want to go over anything more to do with any of those. Hopefully that's been helpful, and good luck for your paper. Bye.